We start by downloading a 3D model. I've gone to a site called Free3D and searched for a pig. Choose a model and download it. Now we have imported it into a program called MeshLab. Reduce the polygons by going to Filters, Remeshing, Simplification and Reconstruction. Then we go down to Simplification, Quadric Edge Collapse, Decimation. The aim is to reduce the polygons as much as possible without losing too much detail. This might take a few goes, a few changes. Now I'm going to highlight the body and just try and reduce that a little more so there's less pieces to put together. We want to export as either a STL or OJB file and then import into a program called Pepakura. Once imported, it'll ask you to orientate your model and also set the scale. Alright, now that we have our model, we want to start planning how we're going to fabricate it by breaking it down into manageable pieces. For instance, I'm going to separate the pig into the following components: body, each individual leg, the head, ears, tail, and lay it out neatly so I can export it as a DXF. Just going through trying to pick different segments to make it as easy as possible to put together. But this is the general workflow. Alright, now we'll adjust our scale so it fits onto either A4 or A3 paper. Make sure the parts are nested on the paper properly, then go to 2D menu and turn on Show Fold Angle. This will show you fold angles. There are two different types of lines, a solid line and a dashed line. The solid line represents a belly fold, fold the part upwards, and the mountain fold is fold the part downwards. We want to then print these pages. Now, to do this process again, but turn off Show Fold Angle and turn on Show Edge ID. As you can see, every edge has a unique ID. So 189 with 189, 190, 190, and so forth. Once you fold all your parts, you just match the numbers and it'll all come together. Right here you can see the different lines. V179 would be actually a 1 degree fold upwards, and M171 would be a 9 degree fold downwards. Time to use your favorite 2D CAD program. I use a software that came with my CNC plasma cutter, which is called Design Edge. It doesn't matter what program you use, just use the one you're most familiar with. The next step is enter all the fold angles and edge IDs and arrange. For the cutting process, we use our water jet cutter. You can easily outsource this to anybody with a water jet or laser. I would avoid using a plasma cutter because of the oxidized edge. You'll have to grind every edge and there's a high chance of getting porosity. We now need to fold all our parts. This process takes a bit of time, but it's worth spending the extra time and getting every angle as close as possible to ensure it fits up properly. Now to sort all the parts into the components. Pick a piece and start tacking up. I like to start with the largest piece first, in this case the body, and then move on to the head. Attach the head to the body, now the ears, and then work on the legs. Now that's all tacked up, time to weld. And then grind. And there the pig's done. Finish with the 80 grit orbital. This video is sponsored by Metal Art and Design. Check out the website link in the description for all architectural metalworking needs. And if you enjoyed this video, don't forget to like and subscribe.